when it is interactive. So feel free to use any of the modalities to ask those questions. You can use that raise hand feature, which I know you guys are all familiar with. You can always drop a question in the chat, or sometimes it's best just to unmute, say, hey, Josh, question for that real quick, and we can go ahead and get those questions answered. So with that, we'll go ahead and hand it over to Josh, and we will get started.
All right, cool. Thanks, Jake.
Absolutely.
Can you guys see my screen?
And
all right, cool. So I had done a training on civil geometry 2 weeks ago. And so this is kind of going to go to the other end of the spectrum. That training 2 weeks ago was how to lay out an interchange and have the civil geometry include intelligence to build, rapid concepts for, ramps and how to tie into side roads and that sort of thing. That was very conceptual of laying out alignments. Now we're going to dig into how do we use civil geometry to detail model. And like we were joking at the start, if you build the intelligence into civil geometry, you can start building civil cells so that it literally is 2-3 clicks of a button to build a curb ramp. But before you get to that point, you need to understand how to build the civil geometry, how to build that intelligence into, the horizontal, the vertical, build some linear templates, build some terrain meshes, and that sort of thing. So I'm going to go one by one with different curb ramps. If at any point you have a question, just unmute, say, hey, can you back up a second? But we'll see how many we get through in an hour because I'm going to go a little bit slower to try to walk through how it works. But I have curb ramp A, C, D, E, and G laid out, ready to go. If I look in here, all I have is a 3D element along my outside edge of pavement. And that's what these yellow lines signify. It may be really hard to see on your end. But we're gonna try to walk through each of these and go through how these curb ramps can be built with constraints. And then if at the end we have a little bit of time, I'm going to show how to build even more constraints on top of it so that you can build a 3D civil cell so you can just drop in a curb ramp as needed. So the first thing I want to talk about is, where does this design intent come from? So if you've never looked at the FDOT standard plans, if you are working in Georgia, North Carolina, I think there are some folks from Virginia. I'm using Florida as my example, but we have all of our standard sidewalk curb ramps in the 522-002 section. And so, all of these are standard, certain dimensions, certain certain different geometrics that are built into it. So we're going to kind of show how that's built into each one. One of the benefits of doing this detail modeling is if you are tying into an existing condition, you can start looking at ADA compliancy, verifying that, all right, I have 2% here and my ramp has to be 1 to 12 or less. It could be flatter for certain, but if it's steeper, then that's, no longer meets ADA compliancy. I need to revise my design and look back at what I'm doing. So the first one to lay out is the CRA. This one, the workflow is to create a bunch of 3D line strings and then to create a terrain from elements from it. So with this case, I'm actually going to focus in on, just the limits of the curb ramp. If you've never seen this, I'm going to talk through some of the dimensions and then we're going to apply them. And I will have this on my other screen because I do not remember this by memory. But as you can see here, we have a 4-foot minimum. And I can zoom in a little bit too. 4-foot minimum for our ramp and our landing. And then we have a 7-foot transition piece for these wings that kind of slope down into this ramp from the nominal 2% cross slope. And if we look down here at section AA, this kind of gives you an idea of what's going on. And so this is actually what I'm going to be using to build my 3D line strings as we go through it. So I'm going to take a screenshot of this. And so this back of sidewalk in this ramp right here is based on 2% from this back of curb right here at 2%. And similarly, this is controlled by 2% at this point. And so as we build the vertical in a second, we're going to project the nominal back of curb height to these 2 points and then just start connecting the dots in between. So let's drag this over and we'll zoom in on our CRA. So the first thing that I'm going to do is I have, part of my crosswalk leading into, into the pavement. I need to offset that 4 feet. So I'm going to go a little bit faster than the last time with some of the tools up here, because I'm assuming most people had watched that one. But if at any point you say, hey, Josh, which button did you press? Just let me know and I'll back up just a second. So the first thing I'm doing is single offset entire element, and I'm going to do my 4 feet. I can keep my feature definition at 4 or at, green dash line. I think that's just fine. I'm not going to mirror it because this is now my landing. And then the next thing I need to look at is my 7-foot wings on either side. So I have my 4, now I'm getting my 7. So again, single offset, let's do 7 feet. Not going to mirror it. So now I have, the limits of my curb ramp in essence. The next thing I'm going to do is establish my curb faces and my curb back. So I want to offset this 1.5 feet to the curb face and then half a foot behind that to the curb back. So pretty simple, 1.5. We'll change this feature definition to curb face, so that is correct. Not going to mirror it, and then build on that with 0.5 feet for our curb back. So now we have the basics, the basic geometry of what we need to do. The last thing I'm going to look at is where my sidewalk back is. So, based on this, we have 12 feet with a landing of, 5 feet or 4 feet. I'm going to do 12 feet, which is, but if we do 4 feet there, that would be 8 feet at this point. And so I actually do something a little bit different. I'm going to offset it from this edge of pavement. What I found with laying out some of these curb ramps is if you offset it from the curb back, sometimes you get recursive projections of profiles. And basically what that means is that if I offset it from this line, if I do projections of profiles, it's not going to solve and you have to rebuild it. So for this case, I'm going to single offset. And let's actually do the partial for our limits. And so if I have a 12-foot sidewalk plus 2 feet for my curb ramp, I'm doing 14 feet. And then change my feature definition to sidewalk back. And this is going to be on the opposite side, but I'm just going to flip it real quick. So if I go here, I can make this -14, and it's in the correct location. So the last thing I want to do is I want to do my landing in here. And so that is going to be 14 feet minus 4, so 10. So a single offset partial. We'll do 10. And I'm sure there's a way you can get this to stick on the right way with entering it differently, but I'm being lazy today. So I have this geometry here. The last thing I need to do is to add my little wing walls. So, from here, it's just an intersection point to intersection point. If we can imagine that 7-foot offset line is there. So sidewalk back, I'm going to do my snap to intersection, and then again to intersection here, and then similarly here. All right, so I have my sidewalk, but also too, we have something going on with the curb itself that we need to control. So if I go back to my screenshot here and that didn't really make it that much bigger, but oh well. So basically what's happening is as this curb ramp goes, this point down here starts to go, starts to slide down here.